Using that the safe distance and clearance distance, we plan a temporary goal for the obstacle, which it chases until while it is avoiding, and once it is cleared the safe distance from the obstacle, it will then again go back to the rerouting and resume its path which is planned before. So here we can see the simulation results which we have conducted for different scenarios of the collision. So first one is side-on collision, where the UAV is changing its course and going downwards and then again resuming its path over there. Similarly, for the head-on collision, it moves in a perpendicular direction, and in the chasing collision, where the obstacle is chasing the UAV from behind, it diverts its course to a random direction perpendicular to its path and then reroutes itself to the original path. So these are some other scenarios which we have tested for the same algorithm. We have also tested two obstacles at a time which are moving closely together. So it successfully avoids both the obstacles and then goes back to its desired path. So in conclusion, we were able to create an algorithm which successfully tackles the moving obstacles in the environment and reroutes its path to avoid those obstacles and then come back to the original path. So in future, we are planning to use this algorithm for more number of obstacles, as well as we plan to integrate the newer technologies like machine learning in predicting the course of obstacles, so we have better chance of predicting its motion and avoiding the obstacle further. So I would like to give credit to my co-authors, Anshum Rankawat, Milan Kumar Pal sir and Rajiv Kumar Das sir, for contributing to the paper. Thank you, sir.
Any questions from the audience?
For the collision, your evidence.
Yes.
Actually, suppose the two targets oppositely they are coming, okay, in a particular point, and you have decided that this is the obstacle. Then what are the things? How you decide that? How? What is the logic?
So when we run the simulation, we decide a course for starting and end point for the obstacle, and it is moving in along that path. So we know when it will encounter.
Now you are defined a path, or automatically adaptive based path selection procedure is there?
So path is defined for both obstacle and UAV while simulation, and we just check if algorithm is avoiding the obstacle successfully or not.
If multiple targets in different directions they are coming,
Yes, sir.
I have seen that there are only two targets in opposite direction.
Yes, sir.
But if I have a multiple your targets,
Yes, sir.
and they are coming in a particular point, then how to avoid that?
So that will increase, like the function which we are using to avoid the algorithm, we will have to modify it for more and more obstacles, and that way we'll be able to tackle. So that will increase the complexity of the code. So which is what we are working on in upcoming time. So which is mentioned in the future scope as well.
There should be, because only two targets obstacle it is not worked through. So
Yes.
multiple targets you have to find out.
Yes.
Okay. Any further questions? I have one or two questions.
Yes.
You have considered only the velocity parameter.
Yes.
The acceleration there, suppose target is suddenly accelerating or something. Obstacle. I have seen only the linear relation
Yes.
between the position using the velocity and time. It is
Yes.
straightforward.
Yes.
So if any of the, suppose your UAV or the obstacle that is accelerating, then what will happen?
So that is yet to be accounted in the code. So this paper focuses on the obstacles moving at the constant velocity. So
Ideally, that will not happen.
ideally that will not happen, but we are building it step by step in the algorithm. So in the next step we will include the different scenarios, and even the random motion of the obstacles will be included.
And another thing, there are many this kind of like the autonomous car we are
Yes.
seeing, Tesla or anything. This obstacle avoidance mechanism is very well known and well researched. So what is the new thing that you are doing here from the research perspective?
Sir, in vehicles, it is we are moving on a 2D plane. So those algorithms are basically A star algorithms or D star algorithms are used in 2D space planning, but that is becomes difficult in 3D space because it is computationally very heavy to calculate the cost of for every point on in the 3D space. So which is why we used RRT algorithms over here. So which randomly generates a point and tries to find the path. And while we increase the number of iterations and give it proper constraints, so it becomes more and more efficient.
Okay, thank you.
Yes.
Thank you for your presentation.